Okay, Chapter 4, Lesson 5, Part 2, with linear programming. So basically what linear program is going to be doing is using our graphing techniques we used yesterday to find where we're going to make the most cost for our word problems. So we're going to be setting up equations like we did in Chapter 4, Lesson 3, and then we're going to be graphing them like we did in Chapter 4, Lesson 5, Part 1. We can use linear programming to make cost-effective solutions in our industrial situations. So basically, it's going to be using your constraints or your inequalities and using those to form a polygonal region and using the points or the vertices on that polygonal region to figure out which one is going to make you the most money. So companies use this when they want to find the most cost-effective production values in their company. So going back to like we did in Chapter 4, Lesson 3, remember that our revenue is, it's not our profit. That's a typo, sorry. Our revenue is how much money we're bringing in or how much you're going to sell your product for. The cost for the company, remember, is our startup cost. It is our production cost, all of those kind of things, paying our employees, running our electricity, all of those. There's going to be more than one equation here usually, especially if there's more than one product being made or if there's more than one startup cost. On these ones, word problems, we're going to do X and Y are greater than or equal to 0 because obviously you can't make negative products. And so therefore, as long as you produce something, you're going to have some money involved. So the money can't be 0 because even if you buy stuff, you're still going to have a cost associated with that. Then what we're going to do is we're going to graph the polygonal regions between numbers 2 and 3. So between your constraints and your X and Y greater than or equal to 0. And we're going to use that to find our polygonal region. And once we've done that, we're going to find the vertices and substitute them into your revenue equation and then figure out which one is going to give you your highest profit. So for the first example here, the owner of a small business manufactures children's playground sets and children's playhouses. This process involves 2 steps. So therefore, we know for sure we're going to have 2 equations. First, you're going to cut your lumber, and then second, you're going to drill and assemble the product. For the playground set, it takes workers 2 hours to cut the lumber and another worker 1 hour to drill and assemble the set. For the playhouse, it takes a worker 1 hour to cut the lumber and another worker 1.5 hours to drill and assemble. Workers can work at most 8 hours per day. The owner makes a $15 profit on every playground set that is sold and a $10 profit on every playhouse that is sold. Use linear programming to find out how many of each product should be manufactured in one day in order to maximize your profit. So I'm going to try to add a slide in on my laptop and see if that will give us room to work on this one. There, perfect. Okay. So the first thing we have to do is figure out what our profit or our what we're making off of each thing. So for step 1, we know that we are making $15 on every playground, and we're going to let playground be my X's, and $10 on every playhouse, which is my Y's. On the second one, we need our constraints or what it's going to take to build these things. So for the cutting, for the playground set, which we said our playground sets are going to be our X, playground, and Y is our playhouses. So it takes 2 hours to cut the lumber for the playground, and it takes 1 hour to cut the lumber for the playhouse, so plus 1Y. And that worker who's cutting can only work 8 hours a day. So that is our cutting worker. The other thing we have to do is drill and assemble. And so that one is 1 hour for the playground and 1.5 hours for the playhouse. And again, that worker can still only work less than or equal to 8 hours a day. Now for step 3, we know that you're going to make at least one playground and at least one playhouse. So both of those things have to be greater than or equal to 0. And now we need to graph. Okay. I wanted to make this bigger. There we go. All right. So for our first equation, remember, number 1, we're not going to graph. That's what we're going to use to determine which one's going to make us the most money. So we're going to start with graphing numbers 2 and 3. So for the first equation, this is not in y equals, so I'm going to subtract 2x to both sides. And then now it's ready to graph, so I start at 8 and move down 2 over 1. And that is a solid because it's less than or equal to, and shaded below. Now I'm going to stay in this triangle box because if I skip ahead to number 3, I know that y has to be greater than or equal to 0, and so does x. So I'm not going to go into the negative quadrants at all. For that second equation, I'm going to subtract 1x to both sides and divide everything by 1.5. So y is less than or equal to negative 2/3 x plus, is it 5? 8 divided by 5 1/3. Okay, so I'm going to start at 5 1/3. 1, 2, 3, 4, 5. And 1/3. And I'm going to go down 2 over 3. Okay. Whoops. And again, this is solid. And I'm going to shade below. Again, trying to stay in the positive quadrant since I know that I have to be above 0. So as you can tell from that, my shaded area that I'm going to be talking about, or my polygonal region, is right here. Now, what I need to do next is I need to find each of the vertices of this polygonal region. So I know this first vertice is 0, 0. This one right here is 4, 0. This one right here is 0, 5 1/3. And this one where they cross right here, that might be the tricky one to find. So what I can do is I could solve this by elimination or substitution, or I could use Desmos. Or I use my graphing calculator. So I have negative 2 1/3 x plus and my other one was negative 2x plus 8. And it says the intersection here is at 2, 4. Good. Now what I do to each of those points is I'm going to put them into my profit equation, which was 15x plus 10y. So for the first one, for 0, 0, I'm going to do 15 times 0 plus 10 times 0, which is $0. which makes sense. If you don't make anything, you're not going to make any money. The second one is 15 times 4 plus 10 times 0, which is $60 profit. The third one is 15 times 0 plus 10 times 5.3, which is $53.33. And the last one is 15 times 2 plus 10 times 4, which is 30 plus 40, which is 70. So in order to make the most profit, it would be in the best interest of our company to make 2 of the X and 4 of the Y. So 2 of the playground and 4 of the playhouse. Okay, number 2. Put a page in, so we're going to refresh it real quick. An automobile dealer has room for no more than 100 automobiles on his lot. The dealer sells 2 models, convertibles, which are your X's, and sedans, which are your Y's. He sells at least 3 times as many sedans as convertibles. He makes a profit of $1,000 on a convertible and $1,500 on a sedan. How many of each automobile should he have in his lot in order to maximize his profit? So first, let's start with our profit equation, which is $1,000 on his convertibles and $1,500 on a sedan. For step 2, he can have no more than 100 automobiles on his lot. So his convertibles plus his sedans can be less than or equal to 100. He sells at least 3 times as many sedans as convertibles. So 3 times the sedans, he sells at least, if not more, so greater than or equal to his convertibles, which is X. Then for part 3, we know that we'll have X is greater than or equal to 0 and Y is greater than or equal to 0. And we'll go ahead and graph. All right, so the first one, X plus Y is less than or equal to 100. I'm going to subtract X to both sides. And since I'm starting at 100, I'm going to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then go down 1 over 1. It's less than or equal to, so it gets a solid line. And less than or equal to shades below. Again, I'm only using the positive X's and Y's, so that's why I didn't go below the axes. Okay, on the second one, I'm going to have to divide both sides by 3. So that gives me Y is greater than or equal to 1/3 X. So I'm going to start at 0 and go up 1 over 3. And it's solid and shaded above. Good. All right, so I can see my points here are 0, 0, which is 1,000 times 0 plus 1,500 times 0, which is $0. This one is 0, 100, which is 1,000 times 0 plus 1,500 times 100, which is 150,000. And then I need this one here, which I'm going to go ahead and put in my calculator real quick. Find out where they cross. So I have negative 1x plus 100 and y equals 1/3 x. And they cross at 75.25. So I have 1,000 times 75 plus 1,500 times 25 is 112,500. So in this case, what it's telling me is that this would make me the most amount of money. So he should sell 0 convertibles and 100 sedans to make the most amount of money. A craftsperson makes leather purses and cloth purses. She can make at most 20 purses per month. She wishes to make at least 5 leather purses and no more than 15 cloth purses per month. Her profit on a leather purse is $5, so it'd be 5x. And her cloth purse is 10, so 10y. Then for part 2, she can make only 20 per month, so x plus y has to be less than or equal to 20. She wants to make at least 5 leather, so x's need to be greater than or equal to 5, and no more than 15 cloth, so y is less than or equal to 15. X is greater than or equal to 0, and so is y. All right, so for the first one, I'm going to subtract y to both sides. So I'm going to have, or x, I mean, negative 1x plus 20. I'm going to count by 5s. So 5, 10, 15, 20, down 1 over 1. And less than, so shade below. Okay, then I have x is less than or equal to 5, or greater than or equal to 5, which would be right here. And greater than or equal to shades to the right. And then I also have y less than or equal to 15, 5, 10, 15. And shaded below. So I can see that this will be my area. Triangle shape. So I have 5, 0 from right here. And then I have 5, 10, 15, 20, 0. And then here I have 5, 15. And it was $5 for every x and 10 for every y. So the first one would be 5 times 5 plus 10 times 0, which is $25. The next one is 5 times 20 plus 10 times 0, which is $100. And the last one is 5 times 5 plus 10 times 15, which I believe is $175. And so in order to make the most amount of profit, she would make 5 leather and 15 cloth.